Parallel axis theorem. So now what if we wanted to find the moment of inertia not around the center axis, but somewhere else? In that case, we are going to use something that's called parallel axis theorem. What is a parallel axis theorem? So in a parallel axis theorem, we want to find the moment of inertia around the center of mass, and then we want to transpose it to our actual axis of rotation. So the total rotational inertia will depend on two things. Rotational inertia about the center of mass of an axis, or center of mass of an object, plus the rotational inertia about the axis of rotation that we want it to be. Okay? So this is going to be given as I total, or I of the axis of rotation will be given by I center of mass plus mh squared, where h is the distance away from the center of mass of the object. Okay, so let's say this is the object and we want to find the moment of inertia of this object at a distance h. So in the center it has the center of mass, and then it is transposed over to find it around here. So this is where the axis is rotating, right? So this object rotates around this particular axis. In this case, its moment of inertia will be given by the moment of inertia of I center of mass plus mh squared, where h is the distance away from the center of mass. In other words, parallel axis theorem, if I was to look at the words, is going to be given by I center of mass plus md squared. Okay? So for example, if we were to look at the hoop, we would find the moment of inertia of the center ring about its center of mass to be equals to mr squared. Now if we were to transpose this to where we want the axis of rotation to be here, then the moment of inertia is going to be this moment of inertia mr squared plus mr squared away. So the total inertia is going to be 2mr squared. So now let's do an example. Two identical solid spheres of mass m and radius r are joined together. The combination is rotated about the axis tangent to one of the spheres and perpendicular to the line connecting them. What is the rotational inertia of the combination? So now let's look at this question. It says two identical solid spheres of mass m and radius r are joined together. So I'm going to first draw these two solid spheres that are joined together. Right? Each has a mass m and a radius r. This has a mass m and a radius r. Right? And they are joined together to each other. Right? And it says that the combination is rotated about an axis tangent to one of the spheres. So let's pick this sphere to be the one that the angle is rotated to the line where it's joined. So these two spheres are rotated. Sphere 1 and sphere 2 are rotated about this particular axis. So what they're asking us to find is what is the rotational inertia of this combination. So for I1, what we are going to do, I'm going to call this I1. So for I1, it is going to be I center of mass plus mh squared. Okay? This is going to be 2/5, we calculated this, mr squared. Okay? And in this case, this h is actually going to be the radius r. Okay? Ooh, too many r's here, right? But this is going to be the radius r. So this implies this is going to be mr squared. Okay? Oops, and there has to be a plus sign in the middle. So 2/5 plus 1 will give me plus 1 mr squared. Right? That is going to be the moment of inertia for I1. Now what about for I2? Well, the moment of inertia for I2 will be exactly the same, which is I center of mass, correct, plus mh squared. But in this case, what will the h be? So its I center of mass will be good, 2/5 mr squared, but what will this h be? Well, this h is going to be that far away. So it means it's going to be 2r for this one and 1r for that one. So this implies it's going to be m3r squared. Does that make sense of how the axis changes between these two spheres? Good. So this is going to be 2/5 mr squared plus 9mr squared. This is going to be 2 by 5 plus 9 mr squared. So I2 will now be equals to 2/5 plus 9. So these two are going to be not the same. They're actually going to be different. Okay? So this implies what is going to be the total moment of inertia? The total moment of inertia will be very simple. It will be I1 plus I2. I total. So you can add this number and that number and come up with an answer. And I'll leave that up to you guys. So this would be what, 7/5 and whatever that one is.